Hello, everyone. Welcome to IBM Developer Online Meetup. Um, this is our 7th webinar with Hair Technologies in the IBM Developer Series. And today we'll talk about blockchain, so I'm super excited. Blockchain and location, to me, that seems like a good combination. And hopefully at the end of this webinar, you'll think the same, that it's a very logical combination to combine blockchain and location-based services. My name is Upkar. I'm a developer advocate at IBM and your host for today. Again, thank you for spending your time with us. As usual, we have my partners in crime, Mohammed and Vidhan from Hair Technologies. Hello.
Hi.
Hello.
And we also have Fawaz today. So I'm sure you've seen Fawaz on this platform before. And also with a webinar with Hair Technology. So Fawaz, welcome back.
Hey everyone.
Good to see you as always. So like always, we'll give you a lot of resources during the webinar. If you're not able to take them down, that's fine. You'll also get an email at the end with the recording as well as the resources. So I'll make sure that goes out. By the way, the webinar is being recorded as usual. The replay will be available immediately after the event ends on the same URL. So come back here if you miss anything, or if you have to leave for work or a work meeting, come back and watch the replay. And also, like I said, I'll post the link in the email. So, for people who are new to IBM Developer, we are a group of developer advocates located all across the world, and we do events like these with our partner companies. Wait, what am I trying to say? Yes. If you want to get notified of future events on Crowdcast that are done by IBM Developer, you'll see a follow button right up on top. So if you click on that, you'll get an email close to when we get started and also when we put up new events. So make sure you do that. If you have any questions about the event today, make sure you ask it in the Ask a Question panel at the bottom. So if you look at the bottom, you should see a couple of links, including Ask a Question. There's also a comment section. I see a lot of you are talking to each other, which is always nice to see. So please make use of that as much as possible. And then finally, we do have a short survey. So we are always looking to improve as IBM Developer team, improve our events, improve our content, see what's working, what's not working. And it's very essential for us to get input from you as our audience. So my request is please fill that out before the event ends or after the event ends. We'll also include that in the email. But yeah, we really look forward to your comments. So with that, I think I'll pass it over to Mohammed.
Thank you very much. So good morning, good afternoon, good evening, whenever you are there. So today we'll have an introduction. Actually, it's a hands-on activities with a bunch of links that we get your support on, is powering the blockchain with location services. We have our shining star from IBM. We have Mohammed Fawaz, Cloud Developer Advocate at IBM. And we have Vidhan. He's our Senior Developer Evangelist at Hair Technologies, and myself. So today we'll have a very, I would assume, like hot topic. Everyone is talking about the blockchain. Blockchain is part of the new technologies that we are hearing and feeling right and left. So artificial intelligence, navigation, self-navigation devices, autonomous, a lot of terminologies. Let me use those things. Part of it is the blockchain. There is a lot of facts, a lot of myth that we will share during the day. We have already the expert on the table. So let's start with what's the what and the why when it comes to blockchain. So if I may ask Fawaz, what's the blockchain?
Hey everyone, my name is Fawaz, and I'm a developer advocate at IBM. And thank you so much for the warm welcome, Mohammed and Upkar. So let's dive into the fact that what is blockchain? So blockchain is the distributed, decentralized ledger, which encompasses both a ledger and a smart contract. So what is a ledger exactly? So a ledger is where you record your transactions in accounting. When it comes to basis of accounting, you look at a ledger like you write down, hey, you're receiving this much, you're outgoing this much, or maybe could be anything. So we took the same concept and we implemented as a data structure, as a system, allowing us to gain many, what do you say, many many
Like
resources.
certification or resources.
Yeah,
Yeah.
uses to make sure that our data is actually protected, our data is on point,
And
our
secure.
data is secured at all times. And what we are actually doing is, with the help of blockchain, we reach out to a really good consensus from everyone who's involved within our transactions. So if
Mm-hmm.
you could take the next slide. So here are some statistics when it comes to the biggest barriers to blockchain adoption. First of all is the regularity and the uncertainty of it. Okay, so there are within a usual infrastructure, we are uncertain of the regularity of the data itself. We have lack of trust among users. Our users may not be trusted. They might input wrong data. The ability to bring networks together. Maybe one area of your organization has a different network, or else another area of organization is following a complete different network there. And separate blockchains not working together, that's also a big issue which people face these days. And the inability to scale. So with your current infrastructures which you have, it is very highly probable that they're not scalable. And moreover, there's an intellectual property concerns that to whom the data belongs to. There's no one who's certifying that, hey, this data belongs to me, or this data belongs to another authority or another area. And then last but not the least is the audit and compliance concerns, which always come in each and every organization as of now, because audit and compliance actually tells you more about your organization. And with the help of blockchain, it actually makes us, with the help of blockchain, it allows us to, overcome many of these issues. And at the end of the day, we reach to a really good consensus from and a really good reporting factor. And if you go to the next slide, we'll talk about a lot of different things. So ledgers are key. Okay, so it is a system of record for a business, and businesses will have multiple ledgers. Now, what can it be? It can actually be a transaction. Maybe you're transferring asset. Maybe you're buying something. Your supplier is actually giving you something to you're receiving products from your supplier as a distributor. And then there are contracts. So if you sign a contract when a transaction occurs, when someone passes you a shipment from Amazon or different companies. So you sign a contract, and that can be actually stored as a transactions. And if the and there's a very good use case here. So an asset transfer onto or off the ledger gives John gives a car to Anthony. That's a simple transaction. Now, when
Mm-hmm.
it comes to a contract, the conditions for a transaction to occur. So a contract actually manages our conditions. And if Anthony pays John the money, the car passes on from John to Anthony. So this is something which we call as smart contracts, making sure that this condition is validated. It's proven to be true. And last but not least, if the car won't start, the funds do not pass to John. It is decided by a third-party arbitrator, which is going to be our authority, and it's more of a complex blockchain architecture. So if you go to the next slide.
So that's the definition of the classical ledger, right? Is that the basic contract as such? And now we are
Yeah.
moving into what we call it like smart contracting. So there is
Yes.
always this type of terminologies of Ethereum. Yeah. So
Yes.
you can give us more insights. Is it Ethereum? Is it Hyperledger?
So let's talk about Ethereum and a Hyperledger. Okay, so Ethereum is
Please.
actually a public open source facilitating smart contract and functionalities. And
Mhm.
Ethereum is actually used to make cryptocurrency. And
Mhm.
Ethereum platform is actually the second most popular blockchain infrastructure after Bitcoin. So what happens is that Ethereum is usually dealing with monetary transactions. Okay, many
Mhm.
organizations use Ethereum and Bitcoin as their payment systems in the current world. Now, when we are talking about Hyperledger, so Hyperledger is an open source blockchain platform by the Linux Foundation, and it supports many infrastructure. It supports IT, finance, supply chain, manufacturing, banking, and various technologies company. And it was actually built with the help of IBM, Intel, Hitachi, and Digital Asset Holdings. And technically, we also, which I will be mentioning further when we go deep down into the presentation itself, is our blockchain platform, which also uses Hyperledger. So what Hyperledger does is that whatever, not specifically monetary transaction, could be any sort of transaction, like how I explained. John is sending his John is giving Anthony a car. So that is an asset. So the transfer of assets can be done through Hyperledger, and this transaction will be recorded into your world state, or your or your blockchain itself. So that
Securely and safely and distributed
security,
as well.
it goes unsaid actually, that
Yeah.
that you have provenance, you have consensus, you have security, you have privacy, and all of these things within Hyperledger itself. So that's the basic idea
Cool.
of blockchain when it comes to that.
Cool.
Okay, we can go to the next slide.
Yeah. So that's distributed ledger.
Yeah. So distributed ledger. So with our current systems, we have a centralized ledger. Let's say party A has one ledger, party B has one ledger. Later, maybe in the months, they'll sit down and they'll compare their ledgers and go like, oh, this is how we end up with our transactions. What happens with the distributed ledger is that there are the ledgers are located in multiple sites, institutions, or geographies, and it allows in transactions to have public
Mhm.
a witness. The transactions are technically public to everyone in the organization itself. So this way, cyber attacks are more difficult because most of your data is encrypted, and your data passes through encrypted, and you will see how the transactions are actually marked in our hands-on session. I will show you something which shows you the transactions which have already occurred on the network which we've built, and also we'll try to make new transactions as well. And to add some more part, the participant at each node of the network can actually access the recording. So every participant on the network can access all of them, all the transactions, but the data visible to them, okay, is it depends on their permission level. So we
Mhm.
obviously use attribute based security, ABAC, and what happens is that according to their attributes, they can see the transaction, but they can actually just see the data which they actually have to see, which they're authorized to see. And obviously, they can also make an identical copy of it. But even then, based on their attributes, they cannot see everything. So just in case, before everyone gets confused that, hey, how are they public but safe at the same time? We have a lot of encryption algorithms, and the entire blockchain itself, it's more based towards the encryption area as well, because that's what people look into when it comes to blockchain.
And part of it also, as you mentioned, the smart contracts.
Yes, the smart contract. So what are smart contracts? So smart contracts are like your own contracts, like how you usually sign a contract in today's world. It's the same thing there. We just call them smart contracts. Why are they smart? So they are actually invoked by a client application. They are like your REST API, and they manage access and modifications in the world state. So what is the world
Mhm.
state? Where all your transactions are involved. So if you are actually querying all your transactions to be seen, they're done through the smart contract. If you're installing, if you're making a transaction, making sure that all the conditions of that particular transaction uh, are met, That is done through the smart contracts. And the chain code, or aka the smart contract, is installed onto peers and nodes instantiated in one or more channels. I will tell you about what are channels and what are peers when we come to the architecture of how everything is built on Hyperledger itself.
Awesome.
So let's look at what our traditional systems, what's the problem actually. So you have participant A, participant B, you have the regulator, you have the auditor, and you have the auditor. And what's going to happen here is that, all of these people have different sorts of records, and none of them are matching. So there's no transparency here. If you see, like, everyone will have unregulated data. Okay, there will be inconsistencies, very hard for people to make sense from the data itself. And storing them is it's technically a very inefficient, expensive, and vulnerable as well. One record goes, you lose it. Maybe let's say participant A loses their records, you're lost from data itself. So when it comes to the blockchain, what is the solution to this? So the solution is, Mohammed? Yeah. So the solution is that we create a shared permissioned replicated ledger. So what's going to happen is that participant A, participant B, bank, auditor, regulator, and everyone will have the same type of records. This way, we overcome the part where we are actually looking at inconsistencies in data, making sure that even if participant A here loses their records, they have a copy of it. And this allows us to actually, make sure that all the participants within a transaction, so let's say participant A is making a transaction with the regulator, they make sure that the other participants in the network, which is our bank and participant B, agree to this transaction. So they are the proof that, hey, this transaction has taken place. And this way they can also see this particular transaction. And when it comes forward to this way we actually make sure that our data is very consistent, and we overcome, we touch all the parts of a blockchain, which is provenance, consensus, and all of those factors.
And that's part of the journey. If you mentioned about the digital transformation, right? So there is a lot of topics with the digital transformation and how we doing the digitizations with a decent database. So what's the difference between the traditional databases and the blockchain as such?
So, like I mentioned many times, okay, traditional databases are centralized. So it's a single point of failure. So when let's say there's a cyber attack happening on your traditional database, once it's gone, it's gone. Until unless you have a backup system. Usually when it comes to an organization, they have backup systems by different variants. But we with the centralized infrastructure, at the end of the day, they will be paying for the loss. And then everyone needs to trust the administrator. So there's one person who's administrating the entire thing, and they need to trust that person. And what if that person itself turns out to be rogue? So you don't have
that one point of failure. Yeah. So it's like
a single point of failure. And then obviously with a traditional database, you can actually there's no immutability or provenance to your data. Maybe I can access it from here. Once I gain access, I can run some, if it's an SQL-based centralized database, I can run an SQL command to just modify the changes. Maybe it could be anything. And that could actually lead to losses or even frauds. And when it comes to distributed databases as well, so people do have distributed databases. It does not elevate the trust issue, because at the end of the day, there will be administrators involved for each and every site, and there will be more copies to worry about and more administrators, like how I mentioned. Now you have a single point of failure with a centralized database. Now imagine that single point being spread out everywhere at this point.
Everywhere.
And maybe one area security is good, but the other area might not be that good. And when when there is a cyber attack, they can actually gain access. And again, there's still the issue of immutability. They can mutate the records, they can access them, and they can actually just They can adjust the data according to their liking. Now, when it comes to blockchain, okay, you are actually looking at a distributed ledger, like how I mentioned. It is in many places. The organizations itself are part of it. The peers are part of it. And then we come with the immutability and provenance. So once something enters the blockchain, you cannot delete it. You cannot edit it, because once you edit it, your chain breaks. We have something called as hash chaining. So once that's
Hmm.
broken, your whole blockchain breaks, and then you can actually deploy it on an untrusted. It can be deployed on an untrusted network. So even if you have an untrusted network, you know your data is secure, and this is something which the traditional database actually cannot handle in the current world.
So
And
that's why the blockchain is a truly technology that can be part of the overall solution. It's not like an end of the world, right? It's like one of the
no.
technologies that's already there.
Yeah.
Then let me ask you the famous questions. Blockchain. People do this with a cryptocurrency. So is it a cryptocurrency?
No, blockchain is not cryptocurrency, and many people get this thing that, hey, blockchain is just cryptocurrency. No, blockchain cryptocurrency is an implementation of blockchain.
Hmm.
So, like all of us have heard about Bitcoin, it's an open source digital currency that uses blockchain technology as its foundation. It's not that Bitcoin came first and then it's blockchain. No, it's vice versa. Blockchain came first and then Bitcoin. And
As a
this can be,
technology base.
yeah, and it's based on blockchain itself. And when it comes to blockchain, and the main reason why they're using Bitcoin is more towards the recording of transactions and its transparency. Okay, no one can regulate Bitcoin, and that's why it's based on blockchain. They can track whether they're tangible or intangible assets, or even digital assets. So this is why they are using blockchain. But please, a blockchain is not based
It's not cryptocurrency. Yeah.
not Bitcoin.
So if we need to let the audience have some information to keep with, so it is technology for business. It is technology that can be part of your overall solution. It can be
Precisely.
part. It can replace your standard or traditional database structure. You can do more out of it.
Yeah.
So what's more when it comes to business?
So when it comes to requirements of blockchain for an enterprise or a business, you need to decide which assets do you have to share. You do not store everything in a blockchain. You do not store
Hmm.
your username and passwords in a blockchain. You can, okay, you can, but then it beats the purpose. It beats the purpose in such a sense that, if a person wants to update their username, or delete their username, or delete their accounts, it won't be deleted from the blockchain, because delete does not exist when it comes to,
Hmm.
in terms of blockchain. There's only update and write and read. So when it comes to a business, they have to actually decide on what assets to share, and then the identity of who are they dealing with. What the they need to know who are the participants within the blockchain network itself, and who needs to know this information. And then the last but not least, the endorsement. So obviously, once a transaction is happening, they need to endorse it. They need to make sure that the transaction is theirs, and they need to make sure that they approve of the transaction. So the participants have to give provable endorsement that, hey, this transaction has happened, and we are actually looking forward to this transaction in the world state when the transaction is complete. So these three are the key points of a blockchain for business, actually.
So and that's why it's a bit complex and it's a
Yeah,
bit different. Yeah. So
precisely.
if you can give us from business perspective the fabric network, how it would look like.
So this is how your fabric network will look like when it comes to very basic fabric networks. There are many other fabric networks which exist, which are billion times complicated than this. Okay, this is the simplest one. So it
Hmm.
actually starts with a client application, and the SDK contacts the Hyperledger fabric network. You have two organization here. and each of them organizations have peer 0 and peer 1, and peer 0 and peer 1 for organization 2. And in the middle is the ordering service. So what happens is that once the organization 1 creates a transaction itself, it goes to the ordering service, and ordering service actually initiates the transaction. And right after that, it sends the transaction to organization 2. Once organization 2 is done, they accept the transaction. Then it is moved to the world state, where, as you can see, there's TXN, where so the blockchain is not stored on your computer. Okay, it's stored on like I mentioned, a distributed untrusted network. So when it goes to the world state, it then gets attached to your chain itself. And that's how it actually works. This is all the actors which involve. And in between these, within organizations, we also have channels which actually segregate people within the organization, because some people don't need to have access to some important data. So this is how a typical blockchain network looks like. This is how it all starts. And then slowly they keep building. They add more organizations, more channels within an organization. They add certification authorities if required. If all of them are trusted, then they really don't need a certification authority. But if they aren't trusted, then they need to add more. And it keeps on building up. And at the end of the day, it's a really huge network.
And I would assume this is how the complexity of the solution architect, yeah. So how this solution architect need to put this blocks of the blockchain and build the whole framework, yeah, as he grow.
Yeah, precisely. So just to wrap up what I said before people get lost. So the application sends a proposal to the endorsing peers. The endorsing peers then simulate the transaction. If there are no issues with the transaction, this is where the smart contract plays its role. That, hey, this transaction does not have any issues, meets all our conditions. The endorsing peer signs the transaction and then returns it back to the application. The application then grabs the signed proposal and sends it to the ordering service. And the ordering service then packages the transaction into a block and broadcasts it to all the peers within the network. In my use case previously, what I did was a transaction between organization 1 and organization 2. This is how one organization is adding block. And then in the end, the peers add the block to their own ledgers, and in the end, it's just added to the blockchain in your world state.
So that's why we need to have this type of cautious, if I need to use the terminology of being cautious, in order to develop or deploy the blockchain. It's not an easy decision. It's not like something like, yeah, tomorrow let's do the blockchain, right? So
it's not
a thoughtful process. You need a thoughtful process out of it.
Yeah, certainly not a one-day task. Okay, it takes. There are specific teams who look into the blockchain. So some of them.
That's why most of the startups, as you mentioned, like, yeah, I will do blockchain technology. Let's start now. Yeah. So I think people need to recognize it's a bit complex process to decide, not even to implement.
Yeah. So obviously, it is a very complex thing, which comes up with, and then comes with our questions. Do we really need blockchain? Okay. So this is a flowchart which I always use personally. Okay, because I'll be very honest. Okay, I'm no professional. Nobody. I'm not 100% at all of my skills. I need to analyze each and every situation. So this is something which I use all the time. Do we actually need to use blockchain? Does a person network need blockchain? So this flowchart is something very useful even for me, and should be for our attendees who are into a blockchain deployment environment. This will allow us to know. So for example, let's take it, if you really don't need a database, then you don't need blockchain. But as we go below, then we get to know which type of blockchain do we need to use. We need to use a public, a hybrid, or a private blockchain. Usually private blockchains are intra-firm, depending on if other firms are like within the firm itself. And when it comes to the public blockchain, you have Bitcoin. Okay, so that's a public blockchain importance. So this is one thing which I would always refer to for everyone here.
So the advice, keep the screenshot. If you're planning to sell
Yes,
blockchain or develop blockchain, keep the
yes, please.
screenshot in your mobile, on your photos somewhere handy, so you can go through this type of discussion even with yourself. And
Yes.
also we need to understand more about the approach, how we
Yeah.
can do this in order to have a successful deployment as such of a blockchain technology within
So
the platform we have.
so this depends on how you solutionize your blockchain. Okay,
Hmm.
you need to discover your pain points. So we have 7 pain points. They see that, oh, these are our issues which we are actually facing. And then you generate those pain points into an idea. And right after that, it comes and there's the last step where you develop use cases for different scenarios within your organization or your use case itself. And you make then the above the previous flow chart comes in where you actually validate. You try out use cases on your you try out use cases and build a network, and you validate that, hey, blockchain is the appropriate approach. And then by the end you have 2 use cases in our case that, hey, they have commercially validated these 2 use cases to be used for blockchain. And then they prioritize and implement, and then we move on towards the implementation side where they incubate the blockchain. They start moving the current data to the new system, which is a very tedious task, but it has to be done when you are slowly moving to a new system. It
Yeah.
happens as a pilot approach. It happens as a batch approach. Like per day, they'll do so many records, and at the end of the day, they have their network.
So if you have your solution now, usually people doing the same ideation session to get the idea itself into an architecture, the same that like people doing the user experience of the screen. Also, you need to have the same exercise. If you need to have the blockchain as part of your solution, you need to have the full ideation and validation proof of concept model with blockchain alone, just to make sure that you can integrate or enable this type of technology with you in order to serve your use cases. So
Precisely.
if we can have more use cases, so how we can use the blockchain in our
So
technologies in our daily life.
So there are many use cases of blockchain. Okay, so it comes
Hmm.
towards consumer type of use cases. You have payments and micropayments. You have goods governance. You have process automation. When it comes to energy, we look at P2P marketplaces for energy grids on the consumer level. Okay, we have payments, and again, payments and micropayments is something which
Hmm.
blockchain usually focuses on a lot in financial institutions, energy, and consumer. And when it comes to healthcare, so healthcare is something which I look into a lot when it comes to blockchain, uh,
Hmm.
because I did my final project in that. So medical health records can be transferred in blockchain itself. And you have industrial goods tracking your entire supply chain in a blockchain, actually. And insurance, since in these days in Dubai, from an insurance you need permission to get your medicines. The insurance approvals
Hmm.
can be done through blockchain. When it comes to the public sector, you are looking at process automation of collection and reporting. Maybe a person makes
Hmm.
a transaction, maybe you touch your knock card on a metro station, that can be also on a blockchain. And when it comes to technology, media, and telecommunications, again, payments come there again. P2P marketplaces for grid
So
computing.
a lot of use cases. Yeah. So
A lot of use
I
cases as
think,
well for blockchain.
yeah. So
A lot.
this is how the thing. So how we can develop, or if we need to start somewhere, can you tell us more?
So first of all, what you need is your open architecture. You need to make sure that since Hyperledger is open source, you need
Hmm.
you need to install it on a Hyperledger on a particular server, and then comes open governance. Anyone can join or contribute, and then you build up from the ground up for the enterprise with
Hmm.
maturity model to help companies move to production. So obviously they'll be
Hmm.
developing for a very long time a blockchain solution usually takes around 6 months, and from there they start building up, and then the performance itself is very high. Okay, the performance, it supports up to 1000 TPS, and then the confidentiality and privacy itself. So there are built-in channels with the IBM Blockchain Platform for isolation and membership services itself. And last but not least, there's modularity and flexibility. We use consensus algorithms and programming architectures. So since something which I really need to mention about Hyperledger Fabric itself is that we have a modular consensus. You can use proof of work, proof of stake. You can use Kafka. Okay, so it's very modular, and usually by default we use Kafka as our consensus algorithm, and then we slowly build up on it. So this is how you usually start your entire Hyperledger Fabric network. And
so we have a good start. We have a good start with the IBM technology. So the platform is ready. Can we have a bit of introduction before jumping to the hands-on?
Sure. So IBM Blockchain Platform. So it's actually an fully integrated enterprise-ready blockchain platform. 100% it is open source. Its backend is based on Hyperledger Fabric. It uses the Hyperledger Fabric SDK to quickly build our applications. It has recently won the design award as well. It's a really good platform. I always use it. It can be actually deployed to Red Hat OpenShift, which is a container platform. It can also be deployed to different clouds. It can be deployed on-prem as well. It can have a multi-cloud deployment, and yeah, that's what IBM Blockchain Platform is. It actually builds the entire network for you.
Meant for business. It's easy to kick off.
Yes.
So if you have your own IoT sensory data or your IoT network, you can use the Watson IoT platform. You can integrate that with the blockchain, the powered with Hyperledger model. And then finally, you can develop your business network applications or your solutions like an end-to-end and deliver it across the region, as you mentioned.
Precisely.
So just to go on to the hands-on. So today we have what you are offering us today, yeah? The food trust, if I put the title?
Yeah, we'd be talking about food trust here. So food trust, obviously, when it comes to, this is IBM's recent research as well. So when the food comes from your farm to the processor, to the distributor, to retailer, we need to make sure that the food is not contaminated, it's not compromised, and it's not spoiling it. So today we'll be looking at the spoilage sector of our use case, where we look at temperature, humidity, expiry, and specifically we'll be looking at temperature, and we'll be storing temperature from an IoT sensor into our blockchain, which I have which we deployed to Kubernetes. Since it's open source, Hyperledger is available, we were able to deploy to Kubernetes itself.
Nice. So can you give us some insight? I will stop sharing the screen so you can get control.
So I'm going to share my screen. This is the exciting part. So, all right. So I will be sharing some links at the same time. Just let me know when you guys can see my screen. Okay, my screen seems to be visible.
Yes, it is coming there.
Okay. So first and foremost, what I usually do is share our GitHub repo on what we are actually working on today. And I'm pasting it in the chat. And there you go. So here we are actually taking just to let you know, we have a temperature sensor, and it's going to Node-RED, and from our APIs, it is being stored in a blockchain network. And we have the orderer service, like how I mentioned. We have CouchDB, we have the world state as well. And we are using two services for this, we are using the IBM Cloud Kubernetes service and Node-RED. And furthermore, for those of you who are interested in implementing it, please do go ahead and look at this repository, it gives really clear-cut instructions to actually look into our implementation. Please do make sure you sign up for IBM Cloud at ibm.biz/here technologies, and you can get your here API key as well. And let's dive right into it. So once you actually sign up for IBM Cloud, you will see the dashboard. So IBM, just to give you a minor introduction about IBM Cloud, is it's a one-stop platform for all your cloud services need. We have around 160 plus services running for your blockchain services, for your data and AI services. I personally focus on data, AI, and data and AI microservices and blockchain. So it's really rather than using my computer, I use IBM Cloud to connect my projects and work on my projects itself. And today we'll be looking at the Kubernetes. So we have Red Hat OpenShift on IBM Cloud. We have Kubernetes on IBM Cloud. And today we'll be using Kubernetes. So to create the service, just write Kubernetes, and you'll be able to create the service. And it usually takes 30 minutes, but you can just wait for that time, and once you're done, you can get back to this. So I'm going to show you my Kubernetes cluster, which I have actually used for this project, and let's have a look at it. So this is the Kubernetes dashboard, which comes in with Kubernetes, and we can see our deployments, our jobs, our pods, our replica sets. So deployments actually face up front, whereas jobs are different type of jobs for maybe loading a database or loading a Hyperledger Fabric network. My pods, how many pods are there for each and every service, and my replica sets are usually used for scalability. And we have horizontal and vertical scaling services, and making sure our ingress is running fine. So some of the deployments which I have here is Node-RED. I'll be diving a bit into Node-RED as well. I have my REST API, which is taken from Docker. I have my organization peers. So we have 2 organizations, 2 peers, one certification authority, and 1 auditor in our network. And nonetheless, we have a lot of jobs. Okay, we generate a Genesis block. This is very technical, in depth, but Genesis is just going to give you the top part of it, that the Genesis block is actually our first block in the blockchain. And this is where it all starts. And then slowly we'll end up on that blockchain itself. And we have join channels and create channels. So this dashboard gives me a lot of insight. So as you can see, I have Node-RED, I have my REST API. I can see how many pods are there, how many replica sets are there, and what is the discovery and load balancing going on in this. So all of these are node-pod application, because on the free clusters, there's no, the load balancers are not available, but you can obviously buy the cluster and apply it there. Yeah. So moreover, let's go into our Node-RED. So this is developed on IBM on Hyperledger, and what we're doing here is that we are actually registering a user and a sensor. So as you can see in our code, we register a user here, and we register a sensor. And we register it to our network. As you can see, the network is working right now. It is submitting transactions, and within the dashboard, so we have an IoT device which gets the random latitude and longitude, and right after that we have a timestamp which generates data for our temperature sensor, and then it adds as an HTTP request, and we are visualizing this data into a temperature. So if you see the dashboard right now, we are getting different temperatures. I will show you the endpoint of it, but Vidhan, would you like to talk about the long here map technologies here?
Sure. Thank you, Fawaz. Hello, everyone. I'm Vidhan, and I'm developer evangelist with Here Technologies. So I'm going to share my screen so that I can show you things. Let me know if you're able to see it.
And share my screen. Okay, are you able to share? Yes, perfect.
Yeah.
Yes.
Okay, so this is the Node-RED part. right? What we are doing here is basically we are mimicking the data of IoT device, and that we are passing to different nodes to create different structures, right? The one structure that I'm going to talk about is the latitude and longitude, right? So basically, the idea is to have an IoT device who's sending your data. Data is going to be your temperature, right, and location, which is basically latitude and longitude. But in our case, we are simply generating it by itself instead of having an actual device. But you can connect that device and you can integrate it with IBM IoT Watson. And then you can work with this. Now, the part that I'm going to talk about, for that, I'll have to scroll this a bit. So this is where we simply have a timestamp, which is basically connecting with all the data generated, right? And the time delay that we are giving here is of, I think, 10 seconds, right? Okay, you can see it here. And after that, we have data generator. This is for temperature, right? Where we are generating a random data float value between -10 and 40. Okay, and this is very simple to generate, and this is one of the easiest way of generating data or creating your prototype. That is what I liked a lot about Node-RED. Similarly, we are generating data for latitude, that is between 12 and 13, and we are generating data for longitude, which is going to be between 77 and 78. So this is for my region, right? And this is for Bangalore region in India, but you can vary it, or if you have real device, it's going to capture the real-time data and send it to your IBM IoT, and from there you can take it out on Node-RED. Now, after you have got the data or you have generated data, you have to perform one task, that is converting that data into whatever format you want it to be. You want it to be an object, or you want it to be a JSON, you can define it. And once you have defined it, we are simply showing it on a dashboard. And you have on the left vertical menu, you have a bunch of links which you can use to create a lot of different structure. We have created a dashboard. So these are the dashboards that you are seeing there. Now, if you scroll down, we have passed it to a function and we are simply checking it if it's working fine or not. So I'm going to simply check it and then I'll move to the map. Okay, so if you go to debug, you can see that the latitude, longitude data is getting generated. Okay, now the next part that you or I'm going to tell about is the role of location in blockchain. So location is an element which is today a key ingredient in almost all the recipe that you're going to build in almost all the technology, and blockchain is one of the very important technology that we have when we think from the perspective of security or a distributed system, right? So here also location plays a very important role, where you are basically capturing where the transaction basically happened, right? So that will give you another dimension of knowing a lot of details about the transaction, about the what do you call in the Hyperledger, I think, right? Now, what we are doing here is simply we have created a node-based structure where we have 3 nodes. Okay, this is for get, and we are defining that, okay, we want to show it in this particular structure or folder, that is /map. This is location. And what do we want to show? We want to show a map, which is basically for all the location that we are getting from IoT device, that those locations are what we require to see on a map. Apart from that, you would also want to see the temperature of those locations. Okay, so for that, this is the code. It's a basic, simple HTML code. I'm going to expand this. Let me know if you are able to see this, or if I need to zoom in a bit. Yeah, I think I can zoom it. Okay.
Yeah, we need to have a bit of zoom.
More? Okay. No,
a bit more. Yeah, it should be okay.
Okay.
Yeah, go ahead.
Okay. Thank you. So it's a simple, one of the good thing is that we can include a very simple structure, right? So I have simply copied and pasted whatever I had created previously into this part, right? And what we had created was an HTML page with a header saying routing to hospital, and some of the scripts. These scripts that you're looking at your screen, these are basically, if you see the links to it, these are js.api.here.com. These are your here mapping library. These are the JavaScript library, which helps you in connecting with the APIs or calling those APIs from the here server. Now you need to do that. you need to do that in almost any mapping library that you are working with. So that is something that you'll have to do. And it's simply copy paste. You don't have to write it from the scratch. And that was in the head tag. Now we are talking about the body tag, where we are simply defining the container where we want to show a map. Now we have defined the container. Next thing that you want to do is you are going to play with the map. You're going to play with the here APIs. And for that, of course, we have to work in JavaScript, because when we talk about showing something on a web browser, or a web application, then JavaScript is the technology or language which basically makes it happen. This is where the magic happens, right? So for that, first thing that you need to do is you need to instantiate platform element or platform object of a platform class. And here you have to pass the API key. Now, this is one thing that you require from here developer portal. So for that, you'll have to go to here developer portal, that is developer.here.com. I think Mohammed will share the link. And there you'll have to grab the API key. And it's very simple. You simply have to create an account. And I might have told this a lot of time, but let's repeat it for the new joinees. Okay, so here we are creating a simple account which only takes your name, last name, first name, last name, your company or any email ID, and your password that you want to have, and checks for if you are a bot or not. And then you can select a freemium account, which gives you around 250,000 transactions per month. And that is more than enough for doing a lot of things, actually. And with this, you are able to test all the APIs. Right? So I'm going to go back. I'm going to log in. I already have one account. And once you log in into this, you will see a project page. Right? Okay, it directly logged me in. And you click on this project page. This is going to take you to the credentials. And on credentials, you have to acquire, since we are working on JavaScript, right? You'll have to acquire JavaScript API key. You'll have to click on create. You can create 2 API key. Copy this. I already have copied one. You can copy this, and you can simply paste it here, and you can delete it and disable it so that nobody else can use it or misuse it. Right. So once you are done with that, scroll down, and I'm going to ignore this error because it's asking me to put the script tag inside the body, but it can work without that. Okay. So scroll down. Now, right now we have hard-coded latitude longitude, but what you can do is you can acquire the latitude longitude, and you can connect the latitude longitude with your HTML, that is template tag, where we have kept our HTML code. And when you scroll down, let me scroll down a bit here. Okay, how does this page scroll? Okay, great. Now we are creating a bunch of variables. Okay. Just a sec. So, okay, I'll show it here only. Now we are creating a variable of default layer just to have a base layer where we want to show the map. And then we are passing the location, latitude, longitude, where we want to concentrate, or which location we want to actually show on a map. And then we are creating an object of map class, which is going to be a normal image, vector image. That is what we are going to call from the server. And we are defining a zoom level. How much zoom do you want from the top, right? And then we are centralizing it to a position, the lat long that we hard-coded, that we provided in the upper lines, the lines above. After that, we have 3 lines of code, which makes your code. This part lets you have the zoom control and changing the layer, and this part lets you drag around or perform dragging option or dragging task in the map. If you scroll down, the next thing that we are doing is simply showing a marker, right? A default marker, and we are showing that marker on the same location, and we are adding that marker to the map. So for that, we are accessing the marker class and creating an object of marker class. And after that, we are simply adding an event listener. The idea here is to just show you a simplest thing that you can integrate quite quickly. And you can do it without working on the node. Also, simply copy paste this code in a HTML file, and you double click it, it will run. So you simply, what we're doing is whenever you click a marker or somebody wants to know that, okay, this is the location of the device and what is the data coming in. So we are already plotting it as latitude, longitude, and we want to show a temperature. And for that, what we want is when we click on a marker, it should pop up something, a dialog or an info bubble. That is what this 47 line is doing. We are adding a listener, And this lizard is a tap function. You simply tap it, and it's going to pop up a bubble, info bubble, that is what we call. And we are creating an object of info bubble class named bubble, passing lat long. And after that, we can pass the dynamic content here, right? But instead of that, we are simply hard coding it right now. Okay, but we are going to make changes in the Git file that we have shared with you. And then we are adding that bubble into our UI, right? The UI object that we created in bubble lines. Now, you simply have to do what? You simply have to click done. Once you are done, you simply have to deploy, right? And you have to simply open this link. I already have done this. Refresh it. And this is the what structure we defined in the div tag, right? And this is the location. And if you click on this, it's going to show you a hard-coded temperature, a string, right? So that is how we do. Now, the main thing is what else you can do or what you would want to do. So there are many things that you would want to do when it comes to location, right? When it comes to playing with the location or playing with or integrating location and blockchain, depending on your scenario, depending on your use case, you can do a lot of things. So I'm going to share this link, which will give you an idea of what you can do here. I've shared the link. Now, what are the things that you could do? First, you would want to see a visualization of the map. That is one thing. If you have an end user who want to monitor all the assets or devices that they have on field, which are being connected with the blockchain structure, you want to see that. For that, you would want to see it on a map, and that is what we did. So we have map API that you can integrate. Apart from that, you would want to search for a location, or you want to do a lot of different tasks, right? Find out any nearby places which could help you out in storing your food. Say, for example, we are capturing the temperature of the food grain, right? Okay, and that is what you can do with the geocoding and search API. Or you would want, say, that the temperature that you are receiving on the Node-RED via Node-RED, and you are finding out that that particular temperature is not right, or there's something wrong, depending on the temperature, you're able to judge that, then you would want to reach there as soon as possible. And for that, you can use the routing API, which will give you the fastest way to reach there, or it will also give you the estimated time of arrival to that your location, so that there's no more damage cost, right? Okay. Apart from that, what would you want to do is you would want to say you have a complete warehouse kind of structure that you are storing grains in different warehouses in different locations, and you have IoT devices on that, and you have a complete logistics solutions also built around it, where you have food trucks who are container trucks, basically, who are transporting food grains from the warehouse to the market or to the distributor. In that case, your company or what you want to build might have a fleet of the trucks. In that case, you would want to involve something with location where you are able to track those trucks, or you want those trucks to be in a certain area, that is geofencing, or if that trucks leave certain location, you want to get alerted, that is geofencing, or you want to have a custom locations where you only want to see on a map that your warehouse is that location, nothing apart from that. You can do that with the custom locations. You can monitor everything with the fleet telematics, or you want to avoid the areas where we have low-hanging bridge where trucks cannot pass. You can avoid that with the help of fleet telematics, or you want to avoid that area where you have toll costs, right? So that your cost of logistics does not increase, or you want to take that also in account. So that is something that is also integrated here. You have,
So
if you scroll,
a lot of features, I would assume a lot of features when it comes to location intelligence. So yeah, thank you. I think we're just crossing the time quickly. So if I can have that screen, please.
Just one last thing. I'd like to show them the transactions itself.
Yeah, sure. Okay.
And we can just go ahead with and I'll pass it over to you.
Please stop sharing.
So yeah. Vidhan shared the links for the documentation. So please go through it. Most of the technologies that Vidhan is mentioning is already there with a lot of examples that we can have. And so I think this is the end of the results, yeah?
So last but not the least from my end about blockchain is that, as you can see, we have a sensor ID, sensor 6, is restoring. These are the IDs of every transaction which is being stored, and we can see what temperature is being stored in each and every transaction. In this way, we can obviously keep the temperature as a secret. And like Vidhan showed, every 10 seconds, we have a new temperature which is being recorded, a new longitude, a new latitude. And in the end, what we get is this as a final result. And obviously, you can deploy the Node-RED application, which I've given you the link for, and you can get the same output towards this.
And also, we can visual that on the map. So we have the gadgets and also visualization of the map.
Precisely.
Cool. So thank you very much. I think we had a lot of information today, especially the topic of the blockchain. It's a bit complex scenarios, right? Right. So I think the audience will refer back to the recording at later stage just to digest a lot of information that we have. GitHub Repo is ready. Just to go through the normal ones. So we are here to help you when it comes to location technology. Today we have the sessions. The last month we had 4 sessions, and it's coming as well next Tuesday. So next Tuesday we have the Node-RED with location. It's more of engaging both technologies and how we can develop this type of. So we have this exactly the Node-RED with a blockchain. We'll deep dive on the Node-RED and location technology. Next week we have more use case. It's a really cool one with social network, like how you can visualize the Twitter with the map and aggregate this type of view as such. So thank you for the listening today. And please make sure to test the technology of the blockchain. It's really nice and cool. And you need to be cautious because of the whole complexity behind it. This is our contacts. If you have anything, reach us there. We can help you. And please give us the survey feedback. We really need to listen to you. Abkar?
Yes, I'm here. Thank you so much for that closing, Mohammed. And thank you, Vedant. Thank you, Fawaz, for your for sharing your expertise. Really appreciate it. So we, like Mohammed was saying, we have our last event in the series coming up next Tuesday. And somebody asked how to sign up or send a calendar event. So I'm not able to send or we are not able to send a calendar event for you to sign up. But like I said, if you follow us on IBM or on Crowdcast, or I pasted the link and you can go and sign up right after this event. It'll literally take you 2 seconds to sign up. All right. With that being said, please do answer the survey. I'll paste the link again in the chat, and we'll see you all next Tuesday. Thank you, everyone.
Thank you. Stay safe.
Stay safe. Have a good week. Bye-bye.